Today we will do ARP spoofing, a man-in-the-middle simulation and detection. So ARP is basically maps IP addresses to MAC addresses on a local network, so devices know where to send data. So first thing we need to do is check IP of both our machines, and before that let me tell you that they are both in the net network because this will keep them in the same subnet. So this is also in net network. So now let's go to our machines. This is our attacker machine and this is our victim machine. So let's ifconfig. So the attacker machine's IP is 10.02.15 and its MAC address is this one, 080027 v4 a105. So this is our MAC address. Now I'll go to our victim machine and let's check. This is the IP of our victim machine, that's 10.026. And let's check our gateway address. So this is our gateway address, 10.021. So let's also check if Wireshark is installed here or not. So let's just Wireshark V. It's installed, and go to our attacker machine and let's see if the Ettercap is installed or not, because we are going to use this tool to do this demonstration. Ettercap-V. So Ettercap is also installed. So before simulating the attack, we need to first understand what is ARP spoofing. So basically in ARP spoofing, attacker tricks both the victim. So the victim, basically this one with the IP address of 10.026, the victim and the router or our gateway. So in this case the gateway is 10.021, into thinking that the attacker's MAC address belongs to the other party's IP. So basically victim thinks that the router's IP is at the attacker's MAC, and the router thinks that the victim's IP is at the attacker's MAC. So let's go here. So as a result, both send traffic to the attacker, who sits silently in the middle, enabling the MITM attacks without changing any IP. So basically the attacker says to the victim that, hey, the gateway's IP is this one and is at my MAC, and the attacker tells the router that, hey, the victim's IP is at my MAC. So the attacker basically fools the victim and the router. So to the victim, suppose this is the victim's IP, the attacker says that this IP is at this MAC address, and this is the MAC address of the attackers, claiming the router's IP belongs to the attacker's MAC. So by doing this, the victim thinks the router is at this MAC, which is basically the attacker's MAC. So he basically does this to the victim, and then again he does the same thing to the router. So to the router, the attacker sends that this is at his attacker's MAC. Basically this is the attacker's MAC address, claiming that the victim's IP belongs to this attacker's MAC. So this effects is the router now thinks the victim is at attacker's MAC. So the result is basically both devices send their attacker's MAC. Both devices send their packets to the attacker's MAC thinking they are talking to each other. So this is basically ARP spoofing, leading to MITM. And ARP cache poisoning is the result of successful ARP spoofing attack. So the victim's ARP table is basically filled with fake IP to MAC mappings, where the attacker's MAC is linked to a trusted IP like the gateway. So this causes the victim to send traffic to the attacker, enabling MITM attacks such as sniffing, modification, redirection, even though the IPs remain unchanged. So that's all for today about the theory. So let's go back to the simulation part. So the next thing we are going to do is enable IP forwarding. So I'm going to explain it later. So let's copy it. Let's go to our attacker machine, let's paste it. So this basically enables the IP forwarding on Kali. This step is crucial because it allows your Kali machine to forward traffic between the victim and the router, so the connection doesn't break. Without this, victim would lose internet access. So let's go to Notepad, and the explanation of this command will be echo1 basically sends the value 1 true or enable to the pipeline, and this part basically writes the value 1 into a system file that controls the IP packet forwarding. So now let's see the Ettercap command, which will be used for doing the attack. So this is the structure of the command: sudo ettercap tqm arm remote, then we'll give our victim IP, and then we'll give our gateway IP. So -t basically means terminal mode, q basically means quiet output, -m means -m, ARP remote basically means MITM using ARP spoofing remote mode. So this is our victim IP and this is our gateway. So I'm going to copy the command and I will go to my attacker machine. I will paste it here. Before pasting it and running the command, I will go to my victim machine. I will start Wireshark Ethernet. So I'm launching the attack. So the attack, now go to the victim machine. Let's wait for a minute or some few seconds. It's capturing the packets. It takes some time. So now I'll write ARP in the display filter. Okay, so let's see this packet. This is a broadcast. Protocol is ARP, and I will go to my address resolution protocol. So here you can see the sender MAC address is 0800 and 05. So this, if you remember, is our attacker's MAC address, and the sender IP address here you can see is the attacker's IP, and the target IP address is the victim's IP. So if we click another packet here, we can see here also the sender MAC address is the attacker's MAC, but the sender's IP here is the attacker's IP. But in the case of target IP, here we can see the gateway address. So basically there are three things here can happen, three conditions can happen. So ARP basically replies generally when there is a request. You can see three conditions in ARP poisoning attacks. Attacker sends fake ARP replies when no one asked, and in normal network one MAC address is linked to one IP, but sometimes you will see one MAC claiming many IPs. This means the attacker is pretending to be multiple devices. Here also you have seen the one MAC address was claiming different IPs, and another case is same IP mapped to different MACs. So this basically indicates tampering with the IP ownership, and this basically means cache poisoning, and all the multiple IPs are resolving to the same MAC addresses. So by analyzing from Wireshark, we can see that the ARP spoofing was done successfully, and this was an example of classic ARP spoofing, where an attacker poisons the ARP cache by sending unsolicited ARP replies claiming ownership of multiple IP addresses using their own MAC. We have seen it, and it also allows the interception or disruption of traffic meant for others. So in this lab, we have seen how to simulate ARP spoofing using Ettercap and analyze it with Wireshark. So this was all for today. Thank you.